Good afternoon all. In the last session we have seen classical sets and its operation. In today's session we will see the properties of classical sets and its mapping to the functions. So coming to the properties of crisp sets, there is nothing but other than fuzzy or classical sets. So crisp sets are classical sets. The following properties of sets are important for further manipulation of these sets. What we are gonna see in the fuzzy sets. So all these things are basics in the classical sets. One is commutativity property. Under this commutativity property, A union B is equal to B union A. If both A and B are two sets, then A union B is equal to the B union A also. It holds good for intersection also. That is nothing but A intersection B is equal to B intersection A also. So commutativity will work in either way. You can union or you can intersect the sets. Both are equal. Next, associativity property. Under this property, if there are three sets, A, B and C are the three sets, A union of B union C is equal to A union B of union C. So even though you can do the union on the left hand side between B and C first, then the resultant can be union with the A. The same thing results for if you do the union between the A and B first, then the resultant can be union with the C also. The same thing holds good for intersection also. A intersection of B intersection C is equal to A intersection B of intersection C. This is nothing but associativity property. So these things we have seen, I think you might have learned in mathematics also. So distributivity property. So how the distributivity property will work means here union and intersection both will come in the same formula. That means A union of B intersection C is equal to A union B of A union B intersection A union C. So that A is distributing between the B set as well as C set. So A union of B intersection C is equal to, so A is distributing with B, A union B intersection A union C also. So in a similar way for intersection also, A intersection of B union C is equal to, again the same, A is distributing to the B and C. It is nothing but A intersection B union A intersection C. Here A is common in both the braces. So that is distributivity property. So next, idempotence property. Under this idempotence property, A union A, here A, B, C, all these are the different crisp sets. So even you can parallelly verify the same thing with the Venn diagrams also. That's what you might have learned in the mathematics. With Venn diagrams also, you can find the same thing in the mathematics also. The same thing what we have seen in the last session. So here A union A is one set. Again, if you are unioning the same with another A, that is same, both A and A, same sets are there. A union A is equal to, again it resultant with the A only. A intersection A also resultant in A only. That is nothing but idempotence property. Next one is identity property. Here under identity property, A union pi, here pi is nothing but null set, right? So if something is union with null means that something only will get it. That's what here it indicates. A union pi is equal to A. If something is intersect with universe of discourse means intersect means common part only, right? That something only will get it. That's what it shows. A intersection x. X is nothing but universe of discourse here. So A intersect x means that is equal to A only, because that common portion is under the entire universe of discourse. A is intersecting with the universe of discourse means that common portion is A only. That's why A you are getting. A intersection pi, which is less here pi. So that's why A intersection pi is equal to pi only you will get it. That means something is intersecting with the nothing means which is common here. Nothing is common or small portion is common. So that's why you will get A intersection pi is equal to pi only. Pi is nothing but null set here. A union x. A is union with universe of discourse. That resulted the universe of discourse. Of course, something is union with universe of discourse means you get the universe of discourse. So these are the identity property. The next one is law of absorption. Here under law of absorption, A union A intersection B. See this properly. A union of A intersection B, right? If see what is there in the bracket A intersection B. Let us assume A intersection B result in the common portion between the set A and set B. The common portion between the set A and set B, again it is union with the A, right? So then you will get obviously A only, because that intersect part is already it is part of the A only. That part of A is again union with the A means the resultant will be A only. In a similar way, A intersection A union B. In the bracket if you see A union B is the term. First you do it for the bracket. What is there in the bracket? A union B. A union B means the entire portion of set A and set B comes in that bracket A union B, right? That is intersect with the A only. So what is the common portion? In the A union B you have A term or A set. Again that is intersecting with the set A. So what is common here? Set A only common. That's why A intersection of A union B will gives only A. So this is the law of absorption. Transitivity property. Under this transitivity property, if A is subset of B, subset are equal to B means B, and B is also subset are equal to C means, then obviously your A is subset are equal to C. That means, for example, if A is having 1, 2, B is having 1 to 5. So A is subset of B, right? Again B is subset of C means 1 to 5. B is subset of 1 to 5, 6. If you see what is A is 1 to, right? What is C? 1 to 5, 6. Obviously A is subset of 1 to 5, 6 only. 1 to is subset of 1 to 5, 6 means A is subset of C only. That's what it indicates the transitivity property. What is involution property? Involution property means here A complement over complement. A bar bar. That is nothing but A complement over complement equal to A only. If you are doing complement 2 times, then it is equal to the actual one only, actual set only. Complement of A is nothing but other than A. Again, complement of A is nothing but that is equal to again A only. That's what it indicates. So these are the properties. And if you go for other properties, law of excluded middle property. Under this property, A union A complement. So A is nothing but one set. A complement means other than A set in the entire units of discourse. So if you combine both or if you union both of them A and A complement, you will get obviously unions of discourse only. Just you visualize that Venn diagram. A is set. A complement is other than A, other than the circle part, what we have seen earlier, and circle part. You are unioning both of them. Then it will become that rectangle box. That is nothing but unions of discourse. Law of contradiction. Here under this law of contradiction, A interjection A complement. A is set A, that is intersecting with the intersection of A and A complement. A complement means other than A. A and other than A. What is the common in that? Nothing. So that's what it indicates. A intersection A complement is equal to null set. So this law of excluded middle property and law of contradiction property are not valid for both classical or crisp sets and fuzzy sets. You'll get something, you'll get it is not valid for both classical and fuzzy sets. We'll see this thing with example also in the coming sessions. So the last property is De Morgan's law. Under this De Morgan's law, A union B complement or A union B bar is equal to A bar intersect B bar. If A union B is complementing means A bar intersect B bar, you get it in a similar way. If it is A intersecting B complement means A bar union B bar, you will get it. So that is De Morgan's law. So next, if you see the mapping of classical sets to the function, what you are doing is mapping of classical sets to the function. So this is an important concept in relating the set theoretic forms to the function theoretic representation of the information. What it means, let us take suppose X, capital X and capital Y are two different units of discourse. X is one unit of discourse, capital X, capital Y is another units of discourse. So under this or inside this two units of discourse, if an element small x is contained in X and corresponding to this element small y is contained in Y units of discourse, so then it is generally termed a mapping from capital X to Y. There is nothing but small x is the element in the capital X units of discourse. The corresponding term to the small x is small y, but that is not in the small x units of discourse. It is in the capital Y units of discourse, which is another units of discourse. So to represent that x to y, function can be written as f such that x to y will represent. So that is the mapping from the one units of discourse to the another units of discourse. So here the characteristic function xa, x subscript a, xa is defined as xa of x is equal to 1 if x is belongs to the capital A. That is nothing but x is belongs to the set A means then xa of x is equal to 1. If x is not belongs to the A means then that xa of x is equal to 0. The corresponding element, if it is belongs to the A set means then your function xa of x equal to 1. If it is not belongs to the A set means then it is equal to 0. Simple. Simply you can correlate the same function with the step function also. Step or simple pulse function, where you can get one value only up for certain duration. That means xa of x is equal to 1 value for certain duration means that portion is belongs to the A set. Other than that, it should be 0. So coming to the membership, xa represents the membership in set A for the element small x in the units of discourse. The membership idea is a mapping from an element small x in the units of x, small x in the units of discourse x, to one of the two elements in the units of discourse capital Y, that is to the elements 0 or 1. So here these are the crisp values, right? 0 and 1. If you want to have a function or map the function between the x to y, that x belongs to capital X and the other two elements in the units of discourse is 0 or 1. So to represent that one, generally we have taken that function f such that x to y. X to y means x belongs to x units of discourse to y units of discourse. For any set A defined on the universe X, there exists a function theoretic set called a value set, denoted as V of A, capital V of A, under the mapping of the characteristic function X. That means for any set A defined on the universe of discourse X, there exists a function theoretic set called a value set, which is denoted V of A under the mapping of the characteristic function. Under the mapping, you will get for any value or any element in one set, if it is function mapping means there exists one mapping value in the other set also. By the convention, null set, which is nothing but pi, right, is assigned the membership value as 0. Null set means that is 0. Whole set means complete set x units of discourse x or whole set is assigned the membership value 1. So two membership value are indicated with 0 and 1. One is null set and the other one is whole set. So those are the crispy sets or classical set. In that only we will get 0 and 1, what we have seen so far. So that's why either null set or whole set. But here fuzzy sets. If you see the fuzzy set, in classical or crisp sets, the transition for an element in the universe between the membership and non-membership is in a given set is abrupt or crisp. It is nothing but in classical set or crisp set, your membership value will change from either 0 to 1 or 1 to 0 abruptly. There is no intermediate values. Either it can go from 0 to 1 or 1 to 0, from yes to no or no to yes, from too extreme low to high or high to low, likewise. But in fuzzy set, the transition of elements can be gradual. So here gradually it can go. So instead of yes to no, we can determine or we can set some other intermediate decisions also. Partially yes, partially no, complete yes, or completely agreed yes. Likewise, different other whatever the possible combinations between the yes and no, yes and no, that we can set, or low and high, immediate low, immediate high. So likewise, or intermediate high, intermediate low. Likewise, you can give what are the possible combination between the low and high, cold and hot. So already we have seen these examples, right? Between cold and hot, you can keep too cold, too hot, moderate cold, moderate hot. Likewise, you can have number of membership functions. So you can set different values also, different functions or values we can set. So that fuzzy set is not a transition of elements in an abrupt manner. It is gradual. It contains the elements that have varying degrees of membership in the set. So different degrees of membership, that's what I have told, right? From cold to hot, we can keep different degree of heat. Even you can keep 0 degree centigrade, 40 degree centigrade, 20 degree centigrade, 60 degree centigrade, 80, 100, to mention that cold and hot, between the cold and hot. So that is possible in the fuzzy set. So if you see the notations in this fuzzy set, for discrete and finite units of discourse capital X, the fuzzy set is defined as A is equal to summation xi is belongs to the capital X, mu A of xi by xi. Here where I is varying from 1 to n. So here what it is means, if you further rewrite that equation, mu A of, if you substitute that I is equal to 1 to n, then you will get mu A of x1 by x1 plus mu A of x2 by x2 and so on, mu A of xn by xn. If you have n number of elements, you will get that n number of finite elements. That's what it is, discrete and finite units of discourse. If you take one example, like in the shown in the figure, xa on the x-axis, on the xa is on the y-axis, x is on the x-axis. This is a triangle form, right? So at 1 on the x-axis, at 1 point it is 0. At 2 point it is the corresponding value is 0.5. At 3 it is 1. At 4 again it is 0.5. At 5 it is again 0. So to get that fuzzy set for this diagram, A is equal to, if you want to represent the same thing in the discrete form, so mu A of x1 by x1, right? To represent that one, that membership value, mu A of x1 by at corresponding point. That corresponding mu A of x1 is the membership value is 0 at 1 point, that's why 0 by 1 plus 0.5 by 2. At 2 point, the corresponding membership value is 0.5. At 3 point, the corresponding membership value is 1, 1 by 3, 0.5 by 4, 0 by 5 again. Likewise, we can represent that fuzzy set for the discrete and finite units of discourse. For continuous and infinite units of discourse, the fuzzy set A is represented instead of points, it is continuous, right? Continuous means you have to integrate. Integration of x, mu A of x by x. It means complete triangle will get continuously, it need to be represent the function values, then that's why integration of x, mu A of x by x. Here the summation and integration sign indicates that union of all mu A of x by x singletons. That means if you add all mu A of x by x values at each point, then that is equal to the summation or integration, right? That's what continuous and infinite. So these are the notation for that fuzzy sets. So simply If it is discrete means at each point what is the function value that will represent. If it is continuous means you will get a continuous line, and you have to add all those singleton points, means all the points mu of x by x you need to add in the continuous and infinite. That's why you get the infinite points here. So this is all about the fuzzy sets. Thank you.